my name is Omar Sanseviero, and today I will talk about open machine learning. To get this started, I would love to begin talking a bit about the history, at least of the last few years. So 3 years ago, OpenAI released GPT-2. GPT-2 is a large language model. It has 1.5 billion parameters. It was trained on 8 million web pages. And GPT-2 is trained with a single simple objective: predict which is the next word. OpenAI iterated on GPT. They launched GPT-3. GPT-3 was extremely impressive. It was able to generate entire website layouts. And also it was able to generate code based on a docstring. So if you've played with CodePilot, this is the kind of technology backing it up. Although the results are quite impressive, OpenAI decided not to release the model due to concerns about malicious applications of the technology. This is understandable, but at the same time, this caused a big issue in the science world. You cannot reproduce the results. This lack of reproducibility makes it extremely challenging to scientifically and rigorously evaluate the model. So 2 years ago, a community called AI, it's a collective of volunteers, they decided to build an open source GPT. You would expect a big group of academics, but this was actually a Discord server, and the initiative started as a joke. But then it turned out to be serious. So AI has been able to do very interesting open science and open source work. They have released large GPT models such as GPT-J and GPT-NeoX. They have been able to open source huge datasets such as the Pi, and there are projects around art generation and much more. It became a huge collaboration. They have published over 10 papers, and it has been a quite exciting alternative for open science compared to GPT-2 or GPT-3. Let's go to another story. Another very famous language model is BERT. BERT was created and was publicly released by a research lab at Google. Training a large BERT model from scratch was a quite compute-intensive task and required lots of data and lots of compute resources, that is money. And although Google released the code for training the model, very few institutions were able to have resources to do a training from scratch. Something interesting happened then. BERT was considered the state of the art, so many research groups were training a BERT model to have a baseline to compare their new research proposals. Each time a research lab wanted to do these baselines, they were training a BERT model from scratch. This led to a lot of issues. For example, people sometimes use different languages, different scripts, different hyperparameters, so it was hard to reproduce the exact same results as the ones published in the original paper. This also has ecological and financial impact, right? If you are training the model again and again, you are at the end having direct impact. And this also means that just the research labs that have significant compute resources can actually create these baselines, right? So if you're talking about universities that don't have the amount of compute resources to train a BERT model from scratch, they couldn't do it. So there was an open source alternative created after some time. At Hugging Face, we created a library called Transformers with the idea of easily sharing pre-trained transformer models. Transformer is the architecture of BERT. GPT-2 is also a type of transformer model. And the idea with the library is quite powerful. It enables people to load models from a shared place with only a line of code, hence solving the reproducibility issue and making transformers available in the hands of everyone. The project was launched almost 3 years ago. It was launched in 2019, and the open source adoption has been extremely wide. Right now it has almost 60,000 stars in GitHub. Thousands of organizations and users are using transformers to share their work. Let's do a third story, but this time, let's say it's your story. Let's say you want to build a news summarizer. The summarization task is quite simple. The idea is that provided a large text, you can think a news article, a blog post, any large text, the machine learning model will make a summary of it. That is a small summarization of the original text. But before going and training a large model for this, the first thing you will want to do is collect and clean a dataset. So there you go, you might have to use thousands or hundreds of thousands of dollars to collect, clean, curate the dataset, explore it. And then after that, you can use the dataset to train the model. But how do you train the model, right? You need to pick the right one. That there might be many different architectures. You might need different teams, try different explorations. You might want to train a model from scratch. And even then, if you get a model out there, the metrics might not be good enough, and you might need to go and collect more data. Similarly, can we do better? Can we do any alternative that is out there in the open? So what I just described before in this new summarization use case can be actually quite simpler. If you've used GitHub before, most likely you have, your approach when doing software-related projects was likely to explore, find repositories with tools to solve some of the problems you have. You don't want to reinvent the wheel, right? You will collaborate with your team by having a shared repository. And once you're ready, once you have a project that might depend on other open source projects, you might open source your work for the whole ecosystem to use. We can do exactly the same with machine learning. Why do we have hundreds of people training the same model for the same thing again and again? How many summarization models there might be out there? What if we could instead have a central platform through which people could collaborate, explore, and discover models and datasets? And that's where Hugging Face comes in. The Hugging Face Hub is a free open source platform with over 30,000 models and 3,000 datasets in which people can easily collaborate in their machine learning workflows. Before going a bit more in this, something that is quite important in the transformers world is transfer learning. And transfer learning has been actually quite impactful in the last few years, not just for NLP, but also for computer vision and other domains. So what's the whole idea in transfer learning? In the classic supervised learning example of machine learning, that's probably the most common one, you will grab a dataset with labeled queries or labeled samples, and you will train a model to generate new predictions. Let's say now that you have a second domain, you will now again train a model from scratch to solve this particular task. With transfer learning, the idea is to extract knowledge from a source task from a domain A, and then be able to apply it to a different task. Right? So for example, let's say that you will train a large language model that will get a statistical understanding of a language, let's say Spanish. Then you can fine-tune this model to solve a particular Spanish-related task, let's say summarization. And right now, since you're using transfer learning, you will transfer the knowledge of this base original large model. And then since you already have this pre-trained model, you don't need that much data, you don't need as much compute resources, and it's actually much cheaper, takes very few minutes or a few hours at most, and it can be quite powerful. This is not just for NLP, this is also for computer vision. This is what convolutional neural networks are doing. You can also do it for speech, biochemistry, time series, reinforcement learning is starting to use decision transformers as well. And we don't know yet, but there will likely be other domains in which people can apply transfer learning and transformers. So today we'll take a brief look at the open source ecosystem. You can observe some of the GitHub repositories that we have. We'll dive into some of these. But across our libraries, we have over 1,000 different contributors without which the libraries wouldn't exist. And that's very important because this is not a couple of libraries maintained by a single company, but by a huge community of different contributors. And across all of these libraries, we have over 60,000 stars in GitHub. But let's go with the first important pillar of this platform, of the hub, right? So one key aspect is sharing models. So the Model Hub is a free open source central repository for models across different frameworks. So people can share transformer-based models here, but also from other NLP frameworks. So if you use Allen NLP, Flare, Spacey, or vision frameworks such as TIM or PyTorch image models, or even other fields from speech, right? ESPNet, SpeechBrain, PyNote, all of these are different open source libraries. And the Hub actually just passed a milestone. There are 30,000 models shared by the community. And the Hub serves as a central sharing point for all these models. And it shines in multiple aspects. It enables reproducibility. So with just a single line of code, people can go and load one of these models. By sharing checkpoints, users can simply load the model, test, and evaluate models, right? So this enables people to actually reproduce the results sharing the original papers. And then with the concept of transfer learning or fine-tuning, people can easily pick a model from one domain for certain task and adapt it for their own particular needs. And this is not just for English, there are over 180 languages on the hub. So let me just quickly show you a bit of this. So this is going to the Hugging Face website. And as you can see at the left, people can filter for things such as question answering, summarization, field mask, which are different tasks that machine learning models can solve. And if you click the plus 14, you can find the different domains for which you can apply these models. So you can search for image classification models or reinforcement learning models or translation. And then you can also filter based on the library, based on the dataset, based on the language. And here at the right, you can see the different models out there. I see this one, GPT-2. So actually, OpenAI did release a small version of GPT-2. It was not a huge model, but a smaller version of it. So what you are seeing here is the model repository. So the concept is quite similar to GitHub. You have Git-based repositories that have version control. So if you click Files and Versions here, you can see all the files in this repository, and you can click here the history, and you will be able to explore all the history of this model repository. Then going back to the model card. So what's the model card? The model card is an excellent way in which people can document what the model does. It has things such as the model description, which are the intended use cases and limitations. It might have snippets of how to use this model, even a section on limitations and biases. These models were trained many times with lots of data from the web, such as unfiltered content from Reddit. So the models can have, of course, many biases and generate very concerning queries. So you need to be very careful in how you use these models. It has further data on how the model was trained, which data was used to be trained, which are the evaluation results. And all of this is actually quite exciting. This is a way in which anyone can go here, read this, understand the model. They can go and see the actual files for this. Or if they want, they can click here using transformers. And with these 3 lines of code, they can load this model in the transformers library. So this was the first thing mentioned here, model card, version control. The third one is interactive widgets. So you can actually play with the model directly in the browser. It may take a few seconds the first time because it's loading the model, but you can actually play with the model directly in the browser without having to run a single line of code. This is quite powerful, especially if you are exploring which model to use. It has things such as TensorBoard hosting. So if people share TensorBoard logs, they can freely host their TensorBoard logs directly in the browser, and it's a nice way to track how different models are doing. And lastly, the last example I would like to show is the evaluation results. So evaluation results allow people to self-report metrics on a specific dataset. And thanks to a nice integration with Papers with Code, you can actually compare all of the different models for a given dataset for a certain task. So this is quite powerful. People can even do things such as report CO2 emissions. And you can use this with any library that you love. So if you're a TensorFlow user, if you are a PyTorch user, if you are using a higher level library or more specialized library, you can use this as well. And the usual workflow is that you can find an open source model in the Model Hub, which was probably shared either by a practitioner or by a researcher. You can find and pick this pre-trained model. You can then go and take a dataset. So you can go and search for a dataset that will be interesting for your use case. And then you can do the fine-tuning of your model with this particular dataset. The open source philosophy is that once you are done with this, you will open source your model for anyone else to use. This will contribute back to the community that helped you by having pre-trained models that you were able to use. So we were talking about datasets, and the next question is, how do you get these datasets? So actually, the Hub also contains datasets. It is a catalog of datasets shared by the community, which you can as well load with a single line of code. It contains well-known datasets such as Squad or the Glue benchmark, as well as many other datasets for classification, question answering, summarization, language modeling, and more. As of now, the dataset hub has over 3,000 datasets. And as for the model hub, each dataset comes with versioning using Git. So you can do reproducibility, you can load different versions of the dataset, and more. There are two key components to the datasets hub. So there is the platform, the web UI, which has the largest hub of ready-to-use datasets for hundreds of languages and different tasks. But there's also a Python open source library called datasets, which allows you to load the dataset with a single line of code. There are no RAM limitations, so if there is a huge dataset which is terabytes, there is something called streaming that allows people to just load the data as needed. And it allows to have very fast iterations and querying. If you don't want to share your dataset with the whole world, you might want to share your dataset, to host your datasets through Amazon Web Services or other places. This is also enabled, so people can also use the datasets library for datasets that are not hosted on the hub. That's totally fine. And then I would like to talk about the third last pillar, which are the most and probably the most interesting. By using open source libraries such as Streamlit or Gradio, and I will talk a bit more about this in a minute, people can easily create interactive demos that allow anyone to try out a machine learning model. This increases the reproducibility of research, and by having them shared in the web, anyone can just go and try this out. So here you can see a small GIF of a demo in which the user selects an image, clicks submit, and finally they get a classification result that says it's an alligator. So how do you build such a demo? How do you share your model as a web app? So until recently, people had to learn some new tools. Many ML engineers actually don't have that much experience in web technologies, for example. Or you cannot probably expect people that are focusing writing papers being able to know about Flask, Docker, JavaScript, CSS, and more. So this can actually discourage people that don't know how to use these technologies. So for each part of this stack, there are different tools. This makes things even more complicated. So after you train a model, you need to deploy it with tools such as Docker. Then you might want to store incoming samples with SQL. And then you will want to build an interactive user interface with front-end technologies such as HTML, JavaScript, CSS, or Svelte, or any other advanced front-end framework. And Gradio is an open source Python library that allows to take each of these steps in a single pipeline, which makes things extremely easy. And you might expect the code to be actually super complicated, but what you see at the left has the three key components. So there are three parts. The first one is this classify skin image. That's a prediction or classification function. And the idea is that this function will take an input and will output an output. Then you will have the types of the input and the types of the output. So in this example, the input is an image and the output is a label. And then once you have this, you can launch this interface from anywhere you want. So this can be from the command line, this can be from a Jupyter notebook, this can be from a Colab notebook. And the result can be seen here at the top right. You have a web interface that anyone can go and try it out. You put an image, you click submit, and then you get if this image responds to a benign or cancerous skin photo picture. So let's build a Gradio demo ourselves, actually. And this is really quite simple. I will do this right now live or in the recording. And here, let's see these three first parts. First, we will install Gradio. That's already done. Then you will have a prediction function. So in this case, I'm not loading any ML model. I'm just doing a hello word or hello name. But the idea is the same. You have a function that takes an input and has an output. And then the last part is the interface, which does all the UI, right? So let's see first what this does. So my name is Omar. I will click submit and I get hello Omar. Nice. So what's the code for this? So first you have a Gradio interface. That's actually quite simple. You have this prediction function. In this case, it's grid. And this prediction function takes an input and an output. So the input in this case is a single text, and the output is again another text. That's it, right? Once you click launch, You get this, you can take screenshots if you want, you can clear, you can do many things. You can adapt the UI if you want something fancier. You can have multiple inputs, multiple outputs. You can run many models in parallel. So there are actually quite a few alternatives you can do within this. But this is the simplest example. But what is very nice is that at the end, the syntax is extremely simple, and all the complexity relies in this prediction function. So let's say that you have a TensorFlow model. So what you can do is just load the model before. So you can load a model here, and then you can just run the inference within the prediction function. So this shows you how generic or how flexible this is. So no matter if you have a spaCy model, a TensorFlow model, a PyTorch model, no matter if what you're using in the Python world, you can very easily use a prediction function to create a nice web interface. Let's see a very quick second example. So this example is actually using GPT-J, which is this model from Eleuthero.ai I was talking at the beginning. And the interface is a bit nicer. As you can see, it has a title. At the bottom, you can see a couple of examples. So for example, I can click here. The moon's orbit around Earth has. I can click submit. And then at the right, I will get which is the output of this interface. So the moon's orbit around Earth has one of several shapes. And then after this, all of the text is completely generated by the GPT-J model. In terms of how this works, this specific syntax is using a already existing model in the hub, and it's using something which is called the inference API, and it is using that under the hood. But the idea is pretty much the same. You have an input, you have an output, and you will have a prediction function that will take care of everything in between. Alright, so let me show you a couple of demos to have an idea of what kind of things you can do, because this is not limited to text. You can do things such as face stylization with Yoyogan. So Yoyogan is a one-face stylization, and in this case, you are seeing a picture of me being stylized as a Disney picture. This is the demo that we were talking in the third use case. So let's say that you want to do a summarization of a news article. So what you can see is that at the right, the user can can paste a URL for a news article. And at the right, the output will be a short summary of the article from the link. Okay, this third one is a voice authentication model and demo from Microsoft. This is using WebLM plus X vectors. And the idea here is quite fun. You will upload two different audio files, and then the model will determine if this is the same person speaking in the two audio files or if these are different persons. This is quite nice. This shows you that these demos are not limited to NLP or to computer vision, but also extend to things such as audio. This is a last example I would like to show you. This is a glide from OpenAI demo. This allows people to write the text, and the image at the right is fully generated by this model called Glide. Alright, so we've been able to create demos, we've been able to run them in Colab. All of this is quite nice. So we built a demo, but now the question is, how do you share this with the community? And for this, there is something, the third pillar in Hugging Face, which is called Spaces. So Spaces is a central platform through which people can upload their own machine learning demos and share them with the rest of the ecosystem. It was launched in October of last year. Again, all of this is open source and free, and this has by today over 2,000 different spaces created and shared by the community. Now let's say that we want to create our own space, so we can just create a new space. You can put any name you want. You can use Streamlit, which is another Python library for creating demos. You can use Gradio, or if you want to go a bit hardcore and you do want to use HTML and JavaScript or something such as TensorFlow.js, you can go with static, which is just custom HTML and JavaScript. You can make this public or private. And again, all of this is based in Git, so you can actually go and do git clone in your computer. And here are some instructions of how you can do it. But if you don't want to download them, you can do everything directly in the web browser as well. So you can just create a file, which is something like app.py. And let's do the same demo we had over here. So let me copy these lines. So the prediction function, let me import radio. And finally, let's copy the interface. So as you can see, the code is exactly the same. I have not changed anything. You have the import radio, you have the prediction function, and finally you have the interface which specifies the prediction function, the input, and the output. Okay, this takes a couple of seconds the first time because this is loading, but at the end you have this web interface that you can try it out. So my name is Omar, and we have exactly the same result as we were having before. You can do things, again, since this is based in Git, you have version control, you can see the logs if you want to see the logs, you can make it public or private, and you can even automatically embed this in other websites if that's something that you would be interested in. And as you can see, this was quite easy to do. You can even specify your own requirements. So if you are using other third-party dependencies, you can use that without any issue. And we have seen that these demos have become quite popular and have enabled people that are not from the machine learning world necessarily to share their models. So, to access and play out with these models. So, for example, a couple of months ago, there was a new space for Anime Gun, and everyone in social media, in TikTok, in different places, were trying out Anime Gun. This was quite interesting because this increased the audience of the machine learning model. And we think we are in a turning point in usage of machine learning. Until now, people that wanted to try out a model were normally ML engineers, ML researchers, software engineers. And if people were sharing models or, let's say, scripts, people had to go to GitHub, people had to open a Google Colab, people had to run actual code. And this was already a huge barrier of entry for other people. Now with Spaces or with these nice demos, anyone who can use a graphic user interface or a browser can access these demos. And this is quite powerful, right? So if you have a model that might have some biases, this kind of open, transparent, public, open source approach will enable the community and a more diverse set of users to try out your model, and this will allow you to find biases in your model, issues, and other things. From a research perspective, this will also make your work public to everyone to try out. And being honest, if you compare just a paper or a paper with a nice open interactive demo that anyone can use, the interactive demo with the paper will be potentially much more impactful and will help people understand what the model is doing. And this will also help avoid cherry picking, increase reproducibility, and much more. So through these three pillars, models, datasets, and demos or spaces, this enables anyone in the community to share their work, collaborate with others, work in a team, just with the same Git-based workflows that people are used to for software engineering with things such as GitLab or GitHub. People can do this for machine learning as well and share their models with the ecosystem. There won't be a single company that will solve NLP or computer vision. It will be a community thing, right? So this is a thing in which everyone needs to get involved. So I hope from this talk you were able to learn a bit more about the open source alternatives and tools that you can use right now to share the amazing work that probably many of you are doing. Thanks a lot and have a nice day.
That was an amazing talk.
Thank you very much.
I'm excited about all of the things Hugging Face is doing. So thank you so much for sharing. Like the cool tools that you guys are building, like I use them, the APIs from that was just like one small piece, I feel like, of like the ecosystem of things that Hugging Face is really doing. And I think that Hugging Face in general is kind of just like the forward thinkers in the space. And I love the open approach. So what do you think why is OpenML so important? Like you've talked a little about the history and kind of a lot of the challenges and things that like Hugging Face has really made so easy that used to be so hard. And I'm curious kind of like more of your perspective on OpenML and where it's going to go and that kind of thing.
Yeah, that's a great question. So our goal as a company, and this is very ingrained in the vision of the founders and all the team members. Our goal as a company is to really enable collaborative machine learning. That sounds extremely broad and maybe a bit ambiguous, but what we want to do is to really enable anyone to work and collaborate in machine learning. What that means is that if you want to use models, you can easily share your models with others, and others can easily use your models, which is extremely important for transfer learning. This also means that if you want to access data sets, they should be public and you can use them. This, of course, is not a this is not a rule that everything should be open source, or not all data sets should be open source. There's, of course, medical data sets that have lots of very sensitive data. But the idea is that, for example, there's lots of research that might publish data sets or very interesting models, but it's very hard to actually use this data or very hard to replicate the results of these papers. And what we're doing is really making this extremely accessible to everyone. And then we launch Spaces, which also makes it extremely easy to access demos and to show demos to people that might not have a technical background even, or a ML background. So now we are starting to explore not just a technical audience, but also how do we help non-technical people to understand what machine learning is. So for example, something that we did a couple of months ago is this thing which is called, let me share my screen, 1 second, which is called task pages. And task pages are a very nice way to understand different tasks. So this is more for non-ML people, but for example, what is question answering? And you can go here and you get a small schema, let's say, of what question answering is. So yeah, I think we are starting to increase our scope. Originally, we were mostly focusing in NLP. Now we are focusing in really all the machine learning ecosystem, which is huge. So now we are doing computer vision and audio and speech and reinforcement learning and other things. But yeah, it's very exciting times.
Yeah, I love that you have that task, because most models is like they're trying to answer a question, right? Every model answers a question, a pointed question. And so the democratization of it, where people can come in and just, you don't really have to know what you're doing, and you can kind of do this like implied AI thing where you can grab these models and just start using them. It's so powerful. And in your presentation, you talked about how you like all those issues and how you've gotten over those with these tooling. So that's amazing. Looks like we have some questions from the audience. So that's awesome. So are the biases declared up front as a model is checked in? How do you make sure that they are ethically sound?
Yeah, that's a great question, and I'm going to share my screen again. So as I talked in my presentation, there is this tool called model cards. Model cards might have sections such as intended uses and limitations, how to use, and they might have a few other things. These files under the hood, they are really just markdown files. So this is just plain markdown. It's not any kind of fancy text. So right now, we don't have any automatic validation, but we do have a few projects ongoing on how to do both automatic bias evaluation. So we are starting to work in tools to analyze which are the biases that models might have. So right now, what we do is that we encourage everyone to do to add these kind of sections, such as intended uses and limitations. I don't know if you know Meg Mitchell. She's one of the most prominent researchers in the ethics for machine learning fields. She joined the company a couple of months ago. So we are doing both technical work and also research in the more high level aspect, let's say, of this. But again, we don't have any automatic thing right now. Anyone can share ML models, but what usually happens is that people just use models that are clearly documented. So it's similar with code, right? You don't go and take any Python library, but instead you really look for documented code and documented models. So most researchers nowadays, when they publish a new model, they are already creating nice model cards that document the biases that they might have. So yeah.
That's awesome. I think it's important. I like that there was a talk about ethics too, because I think so frequently in machine learning, ethics have become they were an afterthought. Like if you think about all the issues that have happened, it's like, look what we can do, but we didn't really think about who could this hurt, and what do we need to consider there with our models. And so there's actually a talk in this track where we're going to talk about different tooling, where the person developing the tool or the model can actually look into the ethics of the model and kind of take on that ownership, because you are posting it. It's almost like a GitHub, like you're posting your model, your code, and everything out there for other people to use. And so when you do that on GitHub with regular code versus, this is machine learning, you do that same thing. You put a README in, you have information on how to use it, and those types of things. So it's really, it's your code, it's on your username too. And I feel like putting that kind of ownership on the people that are submitting things is kind of part of it too, right? Like it's not just, you guys are creating this platform for awesomeness. And I think it's great to think that you guys are hiring ethics people to make sure that you can automate some of that. But then it's also on, I feel like, the individual as well.
Yeah,
Another
I
question.
guess you could see something a bit similar with GitHub. Now that you mentioned this comparison, it's not like all the repositories uploaded by the users are being analyze if they are meeting ethical criteria, but we are working very proactively right now in having very clear guidelines on what kind of things can be shared, how should people document these biases, because it's very unavoidable, not unavoidable, but it's extremely frequent or happens most of the time that models will have biases. So it's extremely important to have very clear documentation to really help users to easily create the better documentation for their own models.
Mm-hmm. Yeah, definitely. So then we have another question here that said, can you compare OpenAI with OpenML?
Yeah, so OpenAI is a company, right? It's a very large company that has been creating some very powerful models. So GPT-3, for example, the inference API that GPT-3 has, and very popular in the last couple of weeks is DALI, the DALI 2 model that has been creating these extremely amazing images. So this is OpenAI, which is a company that was founded a couple of years ago. What they did when they began, they did open source some of their models at the beginning. So GPT-1 was, the original GPT was open source. But after that, with GPT-2, they decided to not release the models due to concerns with ethical issues. That was the public explanation given by OpenAI. But what they have been doing, though, is that they have been making all of the research public, at least. So that means that the paper to reproduce the results are out there. This has many issues because this means that the research is out there, but you cannot reproduce it unless you are willing to spend a couple of millions of dollars. But at least from the more researchy perspective, it's at least an improvement to previous methods in which no one was open sourcing anything at all, nor making the research public. There are, though, efforts from the community to replicate things. So, for example, with GPT, I mentioned GPT-J. Now there's a OPT, which was launched by Meta a couple of days ago, 2 weeks ago or last week, which is a very large GPT model as well. And similarly with DALI, there is a very it's an ongoing effort, which is called DALI Mini by a community member called Boris. Boris. And yeah, this is pretty much the same concept that you write an input. So, for example, astronaut writing horse in the moon, and these images are generated by the model. So this is a smaller version of DALI, but right now there are two very large efforts in the community to create a DALI model on the same scale as the DALI from OpenAI. But yeah, I think OpenAI is a company. OpenML is really a culture of making things open. So it's making open source code, open source models, and really a collaborative kind of mindset.
Well said. Absolutely. I think that DALI model is super cool. And then using large language models in the computer vision space, I also think is really interesting, because CNNs, or convolutional neural networks, have really been the main way to do, computer vision for so long. And then now the way that they're starting to use transformer models to solve computer vision problems, I find, or create computer images, is just so cool.
Yeah, we are starting to see transformers being used. So VIT, vision transformers, are for computer vision. So we see models, transformers models being used for image classification, object detection, but also for reinforcement learning. Now there are decision transformers, and there is also for audio and speech. So Wave 2 Vec 2, for example, is a very cool model to do automatic speech recognition, which means taking an audio and then outputting the text. So yeah, there's very cool, and even in tabular data and time series. So there's very interesting efforts in applying these large transformer models in other domains.
That's cool. So we have another question here. If we use pre-trained models, can we get good results in a specific domain with more limited data, like fine-tuning a large model with a small or medium-sized data set in a specific domain?
Yeah, that's exactly what transfer learning tries to achieve. And actually, transformer models are extremely good for this in NLP. So if you pick BERT, for example, which is a very large, or a largish language model, and then you fine tune it with your own data set, even if you just have a couple of hundreds of samples, so it's really very, very, very little data, you can already get some very cool results. And even then, if you don't have any data at all, there is one kind of model called zero-shot classification. So let me share my screen one more time. So this model, you can see here at the right, there's this small widget. And what zero-shot classification does is that you input a text. So for example, I have a problem with my iPhone that needs to be resolved as soon as possible. This model was not trained to classify based on a set or a fixed set of labels. So it was not trained with these labels. So for example, urgent, not urgent, phone, tablet, computer. The model was never trained to label based on this. But what you can do is with zero-shot classification models is that you can specify the labels that you want in the inference time. So you never train the model directly with these labels, but instead now you're able to do it in inference with zero-shot classification. But that's really just an extra piece of information. But what you said is perfectly correct. That's what most people are using transformers nowadays. They pick these large transformer models. They do fine tuning with their own small or medium data set for their own specific domain. So, for example, I want to use BERT for research, or now I want to use this for even for code. There are some large pre-trained models for code, and you can do fine tuning for your own specific programming language, for example.
That's actually the demo that I did. I used Hugging Face Hub, and I used a model that Microsoft open sourced that was a distilled BERT model. So it was made much smaller, but it was task agnostic. And so then I used a data set to actually train it into a sentiment analysis model. So you could take this distilled, much smaller model, fine tune it with that data set. And then now I have a model. And then I use quantization to actually make it smaller and then deploy it to web. So I actually used the Hugging Face tooling that they have to do exactly that. And it's so powerful because before you'd have to start with nothing, and it would take so much longer. You'd have to have so much more tooling. And then also the model that was trained is now open source. So you could just go grab that model and use it again. So I think like having these model zoos and where you can just go and grab pre-trained models makes kind of like the applied AI space grow even more too, right? Because you can just kind of go in there and use what's there and apply it to your problem without having to, understand all the different operators and machine learning frameworks and that kind of thing.
Yeah, totally.
So let's see, do we have any other questions? Okay, so there's a follow-up. Is it better to fine-tune the word embedding or just take the general word embedding and train just the transformer?
Yeah, so when you train the whole transformer, you are also training the embeddings. So you just input the text, or let's say the tokens, and the model then will learn both the embeddings. So it will learn how to compare the text to an embedding space. And this actually opens some very interesting applications. So there's a very famous library called sentence transformers, which allows to this is extra information, by the way. This is not really answering your question, but it's called sentence transformers, but it allows to map sentences or to create embeddings, not just for words or tokens, but for whole sentences. So what this means is that now you can map directly one full sentence or paragraph or document or essay into an embedding of 256 or 512 numbers, right? So this is really a vector, and now you can do comparison between vectors. This is extremely powerful because if you want to do semantic search, for example, people are using this in production systems right now, or if you want to do retrieval or clustering or paraphrase mining or many things, image search, I don't know, this kind of stuff. It's something very interesting. But in any case, the transformer models are the ones that learn the embedding while you are training it. It's not something that you need to pre-train before.
Great. Well, it looks like we need to wrap. Thank you so much for being here, for sharing your knowledge and all of the cool things that Hugging Face is doing. And thank you to the attendees for hanging out. And if you want to ask Omar more questions, we are going to be in the speaker hangout that is available right after this. You just click on the little yellow banner underneath the session, and we can continue the conversation there. Thanks so much.
Awesome. Thank you. See you now.